Kia ora and welcome to question 3 of the 2008 School Calc exam. This question basically all relates to a problem about a rumour being spread in a school. It's a differential equation type question. It involves partial fractions, hence part 3a having a proof to do with fractions. If they want you to integrate using partial fractions in scholarship, as it's not a level 3 NCEA skill, you'll be given a hint. There is a similar problem in a later scholarship paper. If you look at the 2015 scholarship paper, question 2C, this one here is a little bit harder because you have to derive the solution rather than just show that the solution works. Alright, let's get stuck in. Question A. We've got two fractions added together and we need to show that it equals the right hand side, and P is a constant. Find A and B in terms of P. Okay, so typical partial fractions question. If we've got these fractions here and we put them back together, we would give both the left hand side terms a common denominator. So that first term would need a p minus x in the denominator, so we give it 1 in the numerator. And the second term needs an x in the denominator, so we give it an x in the numerator. And then we add these dudes together, bearing in mind that a, b and p are all constants, and a and b just depend on p. Okay, so that's nothing nasty, that's just adding fractions. And we're told that this is going to equal 1 over x times p minus x. Okay, one last thing we do is we group the stuff together in the numerator of this fraction. AP is a constant, and then the other two terms are linear terms. We've got a b times x and a minus a times x. I'll group that together. And this is equal to 1 over x times p minus x from the question. And if that's the case, if this is going to be true for all values of x, excluding x equals 0 and excluding x equals p, they are values of x that make the denominators 0, then 1 here must equal that for equality. There's two ways to think about this. For partial fractions, you can either say, let's equate 1 with this dude here, and so 1 is just a constant and AP is a constant, but the other term is a linear term. So because there's no x's on the left hand side, right, 0x plus 1, then that looks like theta x. My handwriting terrible. It's like 0x plus 1. So if we had a 0 there, b minus a must equal 0. And then the constant 1 must equal that term there, AP. That's called equating coefficients or comparing coefficients. We get b minus a equals 0 and AP equals 1. Now, a and b, we were asked to find it in terms of p. So we use the second equation there, a is equal to 1 over p, and then the first equation, b is equal to a, therefore b is also equal to 1 over p, and we're done. So that's method number 1 for partial fractions. Another method is to take the yellow expression again, which was 1 equals ap plus b minus a all times x, and this is true for all values of x. Therefore we can substitute values of x in to see what happens. For example, if x is equal to 0, then the whole term at the end would disappear and we would be left with 1 is equal to AP, and therefore A is equal to 1 over P. This is sometimes referred to as the cover-up rule. The cover-up rule because if we substitute values in, clever values, like x equals 0, then this whole term disappears, so we can cover it up. About a minute ago in this video, or 2 minutes ago, I said that x couldn't be equal to 0 for the original expression to be true, but we're just looking at the numerators here. Okay, we don't have any division by 0. So we do pick values of x where the denominator is not defined. The other value of x that we could choose, well, we could choose any value of x. We could use 2, 5, 7, and whatever. But if we choose x is equal to p, then we get 1 is equal to ap plus b minus a times p. But we know that a is equal to 1 over p. And that first term there equals 1. 1 over p times p is 1, which means that the next term must be 0. And therefore, because p is not 0, in general, b must equal a, which equals 1 over p. So this was called the cover-up rule. Substituting different values of x in, because the expression must be true for all values of x, and then working out the coefficients from that. Okay, so we're done. That's the first part done. When a rumour about a teacher is started in a school of size P, it spreads at a rate in students per day that is proportional to the product of the number of students who know the rumour and the number who do not. Find an expression for the differential equation. Well, actually, I'm jumping ahead of time here, but find an expression for the number of students who know the rumour after t days. We're going to need to start off by forming a differential equation. Using the information in the problem, the rate that the rumour spreads in a school of size P, do we get a choice of variables here? The number of people who know the rumour is n, so we're talking about dn dt here. The rate that n is changing is proportional to, so some number times the number of people who know it times the number of people who do not, which is p minus n. School of size P, if 5 people know it, then 5 less than the population don't. And it kind of makes sense for this. This is a very simple model of the situation, and it also comes into disease spreading. Dare I say it, the COVID spread initially was modelled by an equation like this, where the rate is fast when not many people have it. The rate is the rate is slow when not many people have it. As the number of people increases, the rate increases, and as the number of people who don't have it decreases, then the rate slows down again. Now, solving this differential equation, it's a separable one. So we separate the whole right-hand side term down the bottom left, bearing in mind that p is just a constant, the population of the school, and k is a constant. We can just leave that at the right-hand side. I don't usually like writing a right-hand side with nothing left. And then we've got an integral symbol on both sides. So we need to integrate both sides of this to find our expression for n. That's where this part A hint is helpful, because we've already seen this 1 over x times p minus x term. We're just using n rather than x. Part A, 1 over x times p minus x is equal to 1 over p all over x plus 1 over p minus x. Remember, a and b were 1 over p. That looks a bit messy, to be honest, with fractions over fractions. So if I times everything through by p, I'm going to get p over x times p minus x is equal to 1 over x plus 1 over p minus x. It looks a little bit tidier, except the differential equation I'm solving doesn't have that p in the numerator, so I'm going to add it in, make that 1 a p, and then make that pk, times both sides by p. Right. Rather than integrate this dude, which has a non-linear denominator, it's got an n squared in the denominator, I'm going to use the partial fractions relationship. I'm integrating 1 over n plus 1 over p minus n dn. Just replacing all the x's with n's. And then the right hand side, well, that's just a linear function, a if I integrate a constant. Bearing in mind I'm integrating with respect to t for that one. Okay, so integrating 1 over n is ln of the absolute value of n. I don't need the absolute value symbols going forward because n is the number of people who know the rumour and n can't be a negative number. But we keep them in initially. The second term is ln of p minus n with the absolute values around it. And then I need to divide by -1. Okay, remember the chain rule applies still. We've got a minus in front of the variable there. So we divide by the derivative of p minus n, which is -1. Okay, the right hand side, when I anti-diff that, I'm going to get pk times t, and then I need an integration constant, a plus c somewhere, so let's put it in on the right hand side. Okay, I'm going to get rid of those absolute value symbols, like I said. P minus n is also a positive number because the population of the school will be bigger than the number of people that know it until everyone in the school knows it. It's going to be one of the limitations of our model though. We can't make p equal to n because log of 0 is not defined. So, ln of n minus ln of p minus n equals pkt plus c. Put the logs together. Ln of n over, 2 logs subtracted is the log of a division. And then I take the e to the power on both sides to get rid of the natural log function. And then this is typical of NCEA integration excellence questions. I rewrite the right hand side as some constant times e to the pkt, because e to the c is just another constant, and I use power rules. Okay, the question did ask us to find an expression for n in terms of t being in days, so I need to rearrange this equation and make n the subject. It's pretty algebra heavy, but I cross multiply. Expanding that out, I'm going to get one term that has an n on it. I move it to the left-hand side. So I've got n on the left times 1 plus a e to the pkt. And then the term that doesn't have an n in it stays on the right-hand side, a p e to the pkt. And then lastly, division. Okay, and just as a little bit of a breather before we get into finding the values of the constants in this question to solve part C, we're just going to have a look on Desmos and see what this expression actually looks like. Because earlier I mentioned that disease spreading like COVID kind of followed this relationship. So let's have a look at what we've got. And x there is equal to the variable time. P is the constant related to the population size. A is some integration constant, which is related to probably the initial value of the number of people that know it initially, something like that. So actually I can tell you that it's not quite what I just said, because I've got a equals 1 there, but the y-axis intercept is a half. So let's just increase a and see what happens. Okay, when a is 10 there, that looks like 1 over 11 maybe. Okay, so it's kind of related to the initial value, because when I increased it, the y-intercept increased. The population of the school, let's say we've got 10 students in the school. Every teacher's dream, I'm joking. Can't get that y-intercept now. I wonder if a is related to the initial proportion of people that know. Hence why in the question it talked about percentages. So if we get change around a, maybe to something like 5. And then k is related to the growth rate. It's a positive constant. And you can see there that it's kind of tending to, or is tending towards the maximum population of the school. Let's increase the school size to something like our school. For those who don't know, I teach at MAGS. Oh, now we're way off the charts. And we need to slow down the growth of the rumour. Although in our school, if something spreads, it spreads quicker than, doesn't get to the teachers. It's usually the students that know things before we do. Okay, part C. For a particular rumour about a teacher, 0.5% of the students know the rumour initially. Okay, so time equals 0, n is equal to, be careful with your decimals here, 0.05 times p. If I wrote 0.05, that would be 5%. It's 0.5%. The principal will need to act to stop the rumour once more than half of the school's students know it. So we're needing to find the time value when n is equal to 0.5 times p, half of p. And then last piece of information in the question, when 1/5 of the students know the rumour, so when n is equal to 0.2 times p, 20%, the number who know the rumour is increasing at a rate of 0.08p students per day. So we don't know the t value for that either, but we know that when n is 0.2p, dn dt is equal to 0.08 times p. So that should be enough information to find the constants in the question, because we had an a value and a k value, and we've got two pieces of information. And then once we've found those, we can solve for t to find out when the principal must act. Okay, so let's take this information, and we've got our solution to the problem. N is equal to AP e to the pkt over 1 plus a e to the pkt. Let's just check that that one was what I had. Yep. Okay, so first up, time equals 0. We'll sub that one in and see what it gives us. We sub in t is equal to 0 into this expression. We get e to the 0 is equal to 1. So we get AP over 1 plus a is equal to 0.005 times p. We can cancel off the p's on both sides of that equation and solve for a. Okay, if we solve that for a, comes out as 1 over 199. Okay, second piece of information, we are given the differential dn dt, so we don't want to substitute that into this expression here, because that would require us to differentiate it. We go back to the original problem, which was the differential equation we started with, k times n times p minus n, and bear in mind that I didn't change any constants at any point in time throughout the question. And what I mean by that is I kept the k consistent the whole way down into the solution. If you change constants, like for example you might double a constant or add something to a constant and change its lettering, then we lose track of the fact that k came from that original differential equation. And so if I want to find that k value at the end by using the original differential equation, I need to know how I've transformed it. In this case, I haven't transformed it. Okay, so dn dt is equal to 0.08p when n is 0.2p. Okay, we've got p on both sides of that equation, which we can cancel. And then we can divide through to find k. K is equal to 0.08 over 0.2 times p minus 0.2p, 0.8p. 0.08 divided by 0.2 multiplied by 0.8 gives us a half. So we've got k is equal to 1 over 2p there. Be careful, there's still a p. We haven't found k in terms of, we haven't actually found the number of it yet. Okay, then our last thing to do is to find out when the principal may need to act here, and that's when the number of students that know it is half the school. So we can go back to our original solution to this problem and substitute in 0.5 of p. We know that a is equal to 1 over 199. So we've got p over 199 e to the p times kt, but we now know that k is equal to 1 over 2 times p, so pk is equal to a half. That's what I need. I didn't need what k was, I needed p times k. pk is a half. That's my power. A half times t. And then I'm dividing by 1 plus a. Remember, a was 1 over 199. And e to the pkt again. So I've got another pk there as a half. And I'm solving this for t. I can divide both sides by p. Now I've just got one variable there, time. I can solve that and find out the time. Cross multiplication. Move everything that's got a t to one side of the equation. On the left hand side we've got half of 1 over 199 e to the half t. It's the same thing on the right without the half. So if I move the half to the left hand side, from the left to the right, I'm going to get a half. 1 minus a half is a half. Okay, on the right hand side I've got a half times 1, which is a half. Cancel off the halves. Times both sides by 199. Log both sides. Times both sides by 2. Okay, and when you evaluate that, you get the number of days. So let's answer it with a non-exact value so that we can interpret it, see if it makes sense. It comes out to be approximately 10.59 days, which seems sensible.